So we are about to discuss many things regarding ozone. That is, what is ozone and ozone layer, importance of ozone layer, construction and destruction of ozone layer, and equilibrium process, ozone layer depletion, and causes of ozone layer depletion. The mechanisms involved in ozone layer depletion, and then we will discuss about the outcome of a study, of a mission. That is the NASA's mission, that is Phase 3 Ozone Loss and Habitation Experiment or SALT mission, and the outcome of this study we will discuss. Finally, we will discuss about the Montreal Protocol and the Kigali Amendment. Okay, so these are the topics I am going to cover in this lecture. So first of all, what is this ozone? Ozone is just a simple molecule that is O3. Okay, and it has two resonating forms, and the bond angle between 3O atom is 116.8 degree, and bond length between two ozone is 1.278 degree angstrom. And for the last 450 million years, the Earth has this ozone layer, and it is acting as a natural sunscreen in the stratosphere, and this is known as ozone layer. Now, why ozone layer is needed? Okay, it is protecting us from UV radiation, but what are the adverse effects of this UV radiation? UV radiation is harmful for our skin. Actually, UV region is subdivided into three regions: UVA region, B region, and C region. Among them, UVA region has highest energy. It is the highest energy region, and it is the most harmful. And ozone layer is protecting us from this UVA and B region. And but with the depletion of ozone layer, what is happening? This ozone B and C radiation is coming directly to the Earth's surface. And this ozone B radiation, that is that consists of wavelengths from 290 to 320 nanometer. It is affecting our DNA. It is affecting. It promotes skin cancer, and it is also affecting the photosynthesis by destroying the photosynthetic chemicals. Now, UV ray has an immense impact in marine life. What is that? UV ray will destroy our phytoplanktons, and eventually our zooplanktons will be affected when we are not getting this phytoplankton, and the whole marine ecosystem will be affected. And UV ray also it is affecting the vital crop production like rice, wheat, maize, and UV ray is responsible for all those things. So that is why it is very important to protect our ozone layer. Now, how this ozone layer is created? Oxygen molecule in presence of UV light itself will be converted to oxygen atoms, and this oxygen atom will again combine with this oxygen molecule in a third body. A third body collision is needed for this reaction, and it will form ozone molecule. And in a similar fashion, when this ozone is again in presence of sunlight, will be decomposed to oxygen atom and oxygen molecule, and also this oxygen atom will again combine with this ozone molecule to form oxygen, and two ozone molecule also can combine together to form oxygen. So there is an equilibrium for this construction of ozone layer and destruction of ozone layer, and finally this equilibrium has a constant concentration of ozone, and that is what we are. And this layer is protecting us from UV light. Now, concentration of this. Now I am going to discuss about the concentration of this ozone layer in different places of Earth. Okay, in tropic region, the concentration is around 250 Dawson unit, and ozone concentration is we are telling these things. Ozone concentration is represented in Dawson units. And in tropic region, ozone concentration is in average throughout the year it is about 250 Dawson unit, whereas in polar region it is always more than 450 Dawson unit. But when this ozone layer depletion is taking place, this 450 Dawson unit is reduced below 220 Dawson unit. That is what we are telling ozone hole. Okay, the ozone hole is not like that. The ozone is totally absent from that place. Ozone is everywhere surrounding the Earth. But thing is that when this concentration is going below 220 Dawson unit, then we are telling that ozone hole is created. Now, ozone layer depletion. Who has discovered this thing? Professor Dr. Joe C. Farman and workers who was working in the British Antarctic Survey. He has discovered this ozone layer depletion in 1985 and their work was published in Nature in 1985. And the article name was Large Losses of Total Ozone in Antarctica Reveals Seasonal CLOX NOx Interaction. Okay. And in May 1985, Farman's group found that this ozone layer is rapidly decreasing in Antarctica region. Okay, in every year in winter season. That was the first evidence of ozone hole creation in 1985. Okay, but he died in 2013. The person who discovered this depletion of ozone layer. Here, there is a picture of Dr. Joe C. Farman, British geophysicist, and this is one. You see. Yeah. Here it is a pictorial diagram of ozone hole creation. You see, these green regions are showing that there are sufficient concentration of ozones. Especially in this tropical region, the concentration is 250 Dawson or like that. But here, ozone hole, here it was supposed to have more than 450 Dawson unit of ozone concentration here in this region. But it is now depleted beyond below 220 Dawson unit. Okay, and why concentration is high in polar region and low in this tropical region, that we have to understand. Actually, stratospheric wind, that is the stratospheric wind are carrying ozone to the polar region due to Earth's rotation. Okay, that is why our ozone concentration is more in polar region and less in this tropical region. Now, what are the main causes of ozone layer depletion? There are many causes, among them very basic things I am going to discuss here. Chlorofluorocarbons, they are the main causes that everyone knows. But instead of chlorofluorocarbon, people are using hydrochlorofluorocarbons. Okay, and they are widely used as a coolant in refrigerator, fridge, and also as a propeller. Those things are used widely worldwide, and these are the main reason for this ozone layer depletion. And not only this chlorofluorocarbons, nitric oxide, nitrogen dioxide, and nitrous oxide. These three are very harmful elements which are involving in that ozone depleting reaction. And the third point is last point is not last point. Another point is the greenhouse effect and gases. That thing I will discuss later. Because how come these greenhouse gases are affecting our ozone layer? But another thing is that unregulated launching of rockets. These are more harmful even than of these chlorofluorocarbons. That is also one main reason of ozone layer depletion. Now, what is the mechanism of ozone layer depletion? In Antarctic region, it is a very cold place that everyone knows. In winter season, temperature goes beyond minus 90 degrees Celsius. And what happens? The wind blowing in a circular fashion over Earth poles creates polar vortices. Now, in these polar vortices, water droplet come and it creates ice, and also this thing, whatever it is created, these polar vortices and this water particle, they form stratospheric clouds, polar stratospheric cloud or PS. Okay, and now these chlorofluorocarbons will stuck in this polar stratospheric clouds, and they will start an interesting heterogeneous reaction, and this reaction is basically the main cause of ozone layer depletion. This CFC is collected on the surfaces on this ice crystal, destroys the ozone layer much faster than normal CFC does. Okay, this is basically a heterogeneous reaction. That means the molecule will stuck in this stratospheric cloud, and they are now more active for this reaction. Similar destruction of ozone layer also occur in North Pole also, but it is only 10 to 25% and much lesser than what is happening in Antarctica region. Now NASA has conducted one mission during 1990 to the end of 20th century, during these 10 years, that is known as Stage 3 Ozone Loss and Validation Experiment or SOLVE experiment. This is the NASA's high altitude Venom mission. Okay, and the outcome of these results we are about to discuss, and what was studied in that experiment, it was designed to examine the mechanisms that control polar to mild latitude stratospheric ozone levels. So the heterogeneous chemistry involved in this ozone loss are divided into 3 steps. So what is the first step? In first step, HCl and chloronitrate molecule stick to the surface of the polar stratospheric cloud. Now HCl and this chloronitrate react together in a polar stratospheric cloud to form chlorine gas and HNO3. Now this HNO3 will remain stick to the polar atmospheric cloud, and chlorine gas will be released from it, and this chlorine finally what will happen in presence of UV rays, this chlorine molecule will dissociate into fluorine atoms, and that will start this ozone layer depletion, this ozone depletion reactions in a catalytic fashion. So these are the 3 main steps involved in this ozone loss procedure. Now the other heterogeneous reactions which are involved in ozone loss, these are summarized below. I think many people may not understand this reaction, so still I am discussing that N2O5 in presence of water molecule will generate HNO3, and chloronitrate in presence of HNO3 will form HCl and HNO3. Now chloronitrate will react with, this is the main reaction, that was the outcome of this SOLVE mission. That is, chloronitrate will react with HCl to form chlorine gas and HNO3. So this is the chlorine atom. This is the main cause of this ozone depleting mechanism. So what we can do it nowadays, instead of chlorofluorocarbons, people are making hydrofluorocarbons. Okay, that without this chlorine atom, we are making substitute of this chlorofluorocarbons so that we can minimize chlorine emission to the atmosphere. And this there is one example. So the example is hydrofluorocarbon 410A can be used instead of hydrofluorocarbon 22. This is our hydrofluorocarbon 22. This one, hydrofluorocarbon 22, and this is hydrofluorocarbon 410A. We can see that here we have they have successfully removed this chlorine from this combination of molecules, that is hydrofluorocarbon 410A. So these are known as hydrofluorocarbon, and the previous molecules were known as chlorohydrofluorocarbons. So by this way, people are eliminating these chlorofluorocarbons and both hydrofluorocarbons by means of only hydrofluorocarbons. Okay, so now we are going to discuss about the Montreal Protocol that already my previous speakers has already discussed that what was there in Montreal Protocol. So Montreal the ozone hole paper was published in 1985, and Montreal Protocol was implemented in 1987. So what was the main objective of Montreal Protocol? So to diminish the production and consumption of ozone depleting substances like chlorofluorocarbons. This was the main objective. So following Montreal Protocol only, people has replaced these chlorofluorocarbons with hydrofluorocarbons. And now after that time, till date, this Montreal Protocol was amended 5 times. And lastly, the amendment was done is known as Kigali Amendment. It was the amendment was this conference was conducted in Kigali, Rwanda. The Kigali is the capital of Rwanda, and that is why it is known as Kigali Amendment. And in this amendment, they are now telling that we have to diminish use of hydrofluorocarbons also. Why? Because it is a potential greenhouse gas. And now I am going to discuss how these greenhouse gases are about to create problems in this ozone story. Why? Because you see this polar stratospheric cloud that is forming at minus 90 degrees Celsius. Okay, and what is happening? This greenhouse gases are trapping all the means. It was actually forbidding to release the heat from the earth. Okay, so that is why that polar atmosphere stratospheric cloud will not be destroyed. To make this cloud, we need more and more heat that should go to the stratosphere. But our heat is actually trapped in troposphere. That is why this greenhouse gases also has immense effect on this ozone layer depletion. So finally, I want to thank everyone for your time and to come to participate in this program. And I have taken references from NASA and NASA Goddard Space Flight Center website, and also there is an environmental science book, that is the Kaushik and C.P. Kaushik's book. And also you can go through for more information British Antarctic Survey website. And for this more to learn more about this Montreal Protocol and Kigali Amendment, you can go through the United Nations Treaty Collections, the World Trade Organization website, and also US Government Department of State website for more information. Finally, thank you everyone for your time, and I want to thank everyone from the Department of Chemistry to make the event successful. Okay, thank you everyone.